So good morning. A very warm welcome to Defense Pro X Level 1 training, day 2. So the topics for today are BDOS protection, DNS protection, SYN flood, out of state, and basic traffic filters. So these are the topics that we are going to cover today. I have got a few messages that a few participants are unable to get past the lab. I mean, they were not able to onboard the Defense Pro onto the cyber controller. We can check those issues out, okay, post the session. Once we complete the presentation, I can have a look on that. But as of now, let's continue with the presentation part. Okay, so these are the topics that we'll be covering today. And again, we'll have a lab session at the end, wherein you can just continue with from where we left off yesterday. Okay, so the first topic for today is related to BDOS. So let's start. So the agenda would be something like this. We'll be explaining what is behavioral analysis and how we can tackle or mitigate certain kind of attacks, which the BDOS protection helps to tackle. Then some principles about BDOS, how it works. So before that, there's a small video which I would like to share.
What is behavioral-based DDoS protection? Hi everyone, I'm Eva and welcome to another Radware Minute. Traditionally, DDoS protection solutions rely on rate-limiting technology, which limits the maximum amount of total traffic to the organization and blocks all traffic above this limit. This leads to false positives and legitimate traffic getting blocked. Behavioral-based DDoS protection profiles traffic behavior and can accurately distinguish between legitimate traffic and malicious traffic. It relies on AI, machine learning algorithms, to determine in real time the intent of the traffic requesting to access a certain service. With these algorithms, we increase detection accuracy and minimize false positives. Behavioral-based DDoS protection ensures no service disruption to legitimate users accessing your services and enables your business continuity, even during a massive DDoS attack. Thank you for joining us on this Radware Minute, and stay safe.
So that was a small video which explained what behavioral DOS technology is. So this is a patented technology from Radware, which provides you real-time protection against zero-day network flooding kind of attacks. So what kind of attacks does BDOS protect you against? So it can protect you against TCP SYN flood attacks, TCP SYN plus ACK floods, finish floods, reset floods, fragmented floods, UDP, ICMP, and IGMP floods. So these are some of the flooding kind of attacks or volumetric attacks which the behavioral DOS engine can mitigate in near real time. Okay. So how it works? So here we have four phases in which the behavioral DOS works. So there are literally four phases through which the behavioral DOS engine learns, detects, and characterizes and mitigates a particular attack. So I'll explain it right away that how this functionality works. So let's get started. So the first phase is your learning phase. So first phase is a learning phase. So during peacetime, so whenever there is no attack or when you have started the process, it starts with the learning phase. So Defense Pro is learning traffic characteristics. So it is learning traffic characteristics. Okay. So what does it learn during this particular period? So the production traffic is passed via the Defense Pro. During the peacetime, the Defense Pro will be learning certain traffic characteristics. Now, what are these traffic characteristics? So primarily, it learns two things. First is the rate, okay, and second is your rate invariant part. Okay. So first is the rate and second is rate invariant. Now, what is rate? What is rate invariant? So rate is the number of packets per second. Okay. So rate part is number of packets per second. Now it could be, let's take an example. If it is related to SYN, then the number of SYN packets that we are receiving per second. Okay. Or it could be the number of reset packets per second. Or it could be the number of, let's suppose, finish packets per second. Okay. So during peacetime, the defense pro would be learning that how many packets of SYN are we receiving per second, how many reset packets are we receiving, how many finished packets are receiving, etc. So the packets can vary. Okay. The type of packet can vary, but we are primarily calculating the number of packets per second. And based on this, we will have an idea, or we will create a baseline that this is the expected rate that we are receiving during peacetime. Okay. So based on the incoming traffic characteristics, we create a baseline that this is the amount that we are receiving during peacetime. So that is the rate part. Next, we have rate invariant. So what is rate invariant? The percentage of a particular type of packet, okay, percentage of SYN with respect to the total traffic that we are receiving. So the total traffic can be comprised of SYN packet, reset packet, finish packets, SYNAC packets, okay, all kind of packets. So what is the percentage of SYN packet with respect to the total traffic? So that is your rate invariant part. So during peacetime, we are learning these two things, number of packets per second and the rate invariant part, which is percentage of a particular packet with respect to total traffic. Okay, so this is also known as TCP uh, flag distribution. Okay, so we are learning TCP flags distribution. We are learning the rate, which is number of packets per second, also the bandwidth part as well. So how many bandwidth are we consuming? So these three things we are learning during peacetime. Okay, so this is done during the learning phase. That means we calculate rate and rate invariant part and gather traffic statistics. Next is detection phase. Okay, so during detection phase, DPX is primarily trying to understand whether an attack has started or not. So during detection phase, we are checking whether the attack is detected or not. Okay, whether the attack has started or whether the attack has been detected. How does the DPX detect that there is an attack? Okay, so Defense Pro checks whether there are deviations. Okay, so Defense Pro checks whether there are any deviations with respect to the rate and rate invariant. Okay. So during the detection phase, we are basically learning the rate. During the learning phase, we have already learned rate and rate invariant part, right? So during the detection phase, DPX checks whether there are any deviations with respect to the rate and rate invariant part. Now, if both rate and rate invariant deviate from the baseline, then we characterize it as an attack traffic. Okay. We characterize it as an attack traffic. So this is how we detect whether there is an attack started or not. How? By checking whether both the rate and rate invariant are deviating from their normal baselines. And once they both deviate, then we characterize it as an attack. If any one of the part changes, like only the rate changes, but rate invariant remains constant, we are not characterizing it as an attack. Okay, only when both of them deviate, then we consider it as an attack. So let's suppose both of them deviate and we have characterized it as an attack. Then the next phase is characterization. So during the characterization phase, the defense pro is creating a real-time signature. So during this characterization phase, a defense pro is creating a real-time signature, which is used to block the attack. Okay. So based on the incoming traffic that we are receiving, the attack traffic, I mean, the defense pro is checking what parameters can we use, okay, in order to mitigate an attack. Okay. And we create a real-time signature. This real-time signature can be attached to the attack traffic and it would be completely mitigated. So during the characterization phase, we are creating real-time signature, which is also known as RTS. Okay. Then we have the final mitigation phase. During the mitigation phase, basically the real-time signature is attached. Okay. It is attached to attack traffic. Okay. Once it is attached to the attack traffic, only the only the attack traffic is dropped. Okay. So only the attack traffic is dropped, legitimate traffic is allowed to pass through. Okay. So only the attack traffic would be dropped whenever RTS is attached to the attack traffic, and this happens in the mitigation phase. Now, one more important thing, characterization phase and mitigation phase are working in closed feedback loop. That means mitigation phase will inform the characterization phase, okay, that the real-time signature is working properly or not. I'll explain this later as well. But just for now, remember that the mitigation phase and the characterization phase are working in closed feedback loop. That means mitigation phase will inform the characterization phase that the real-time signature is not working properly, use some other parameters or make any modifications in the real-time signature and update the real-time signature. Okay. So they help each other by giving the feedback and getting close to the best signature possible. So these are the four phases. I'll just repeat once more as a summary. During the learning phase, that is during peacetime when there is no attack, Defense Pro is learning traffic characteristics. It primarily calculates two things, the rate part, which is the number of packets per second. It could be SYN packets per second, reset packets per second, or finish packets per second. With the help of this, we will create a baseline that this is the expected traffic during peacetime. So that is your rate part. Rate invariant is the percentage of a particular packet with respect to total traffic based on the TCP flag distribution. All this is learned during the learning phase. Next is detection. The Defense Pro is basically trying to detect whether there is an attack or not. How it detects? It checks whether there are deviations with respect to the rate and rate invariant, which we have learned during peacetime. If both of them deviate, then there is certainly an attack. Next phase is characterization phase. During this phase, whenever an attack is detected, Defense Pro make sure that a real-time signature is created based on the parameters which are learned during the attack. Okay, so the best possible parameters are selected and they are chosen as real-time signature. Okay, and this real-time signature is attached to the attack traffic and it is dropped during the mitigation phase. Only the attack traffic is dropped, legitimate traffic is allowed to pass through. Okay. The characterization and mitigation phase works in closed feedback loop. Okay, they are working together. The mitigation phase informs the characterization phase that the real-time signature is not working properly. Try some other parameters as well or make some combination changes. Okay, and post that characterization phase creates a new real-time signature and is then attached to the mitigation to the attack traffic and it is completely mitigated thereafter. So these are the four phases and all this is done automatically. You do not have to do any configurations as such. You just have to specify the initial bandwidth and turn on the BDOS functionality. Rest everything is taken care of by the Defense Pro. Okay. So you do not have to create a real-time signature. It is created on its own. As soon as an attack is detected, Defense Pro will create a real-time signature within 18 seconds. Okay. So within 18 seconds, you will have a real-time signature which will be attached to the attack traffic and it would be completely mitigated. So all of this is automated and hence this is a great tool to have. And most of the flooding kind of attacks is mitigated using these this method, which is behavioral DOS engine. So that's what is mentioned here. So just a summary for you. So learning phase gathers traffic statistics, rate and rate invariant. Detection phase, decision-making mechanism to identify an attack based on the rate and rate invariant part. Characterization phase creates a real-time signature based on the attack characteristics, and mitigation phase blocking only the attack traffic that matches the real-time signature. So these are the four phases in which we work. So first learning phase. So during the learning phase, we are learning the traffic. So as you can see on the left, all the packets we are learning. So we are learning these two things, which is the rate part, which is the number of packets per second, and rate invariant, which is nothing but your TCP flag distribution. Next, we have detection phase. So during the peacetime, it looks something like this. Okay, during peacetime, the graph looks something like this, as you can see. And during the detection phase, the Defense Pro is basically learning what is the rate and rate invariant part, whether they are deviating or not. So as you can see here, the rate and rate invariant part are both deviating. The rate is high as well as the rate invariant part is also showing certain deviation. Okay, so now if both of them are deviating, then the degree of attack would be high. So degree of attack is a parameter, okay, which will basically let you know whether there is an attack detected or not. So if the degree of attack is high, then there is certainly an attack detected. Okay, then there is certainly an attack detected. So in this case, it is a TCP reset kind of an attack which is happening. Okay. So now if we go, so we have detected an attack. So I'll explain with this particular graph how we can consider it as an attack. Okay, and some examples as well. So let's suppose the rate. So on the y-axis, we have the rate part. So this is the y-axis in this case. So y-axis, this is the rate part. Okay. On the x-axis, we have the rate invariant part. Okay. So on the x-axis, we have the rate invariant. And on the z-axis, okay, we have the degree of attack. On the z-axis, we have degree of attack. So let's consider the rate is very high. Okay. The rate is very high. Let's suppose this is a there is some sale going on for an e-commerce website. Okay. And hence there are a lot of requests coming from the clients. So during the sale, there would be a lot of requests which are coming towards the e-commerce website. That means the number of packets per second would be considerably high in this case. Okay. So that is the first part. The rate is high. So that's what we have marked here. So the rate part is high, but the rate invariant part, which is your TCP flag distribution. Okay. So TCP flag distribution is still normal, because these are legitimate requests. Now, these are not an attack traffic. These are legitimate requests, and hence the TCP flag distribution remains the same. That is the SYN, SYNAC, and ACK is all under normal distribution scenario. Okay. So it is normal, and hence these kind of traffic we are not considering as an attack traffic, because these are legitimate requests. Okay. So the rate is high, but the rate invariant is still normal, and hence this is not considered as an attack, as you can see here as well. So if we draw, let's suppose the rate invariant is somewhere here, if what is detected, and if we correlate, this somewhere here. Okay, so this is the matching. So degree of attack is low. So degree of attack is low, and it is well below the attack area. So it is well below the attack area, and hence this is not considered as an attack, because rate is high, rate invariant is low, only one part is deviating, the other part remains constant, and hence we are not categorizing this as an attack. Let's take another example. The rate is high, okay. Also the rate invariant part is high, somewhere here. In that case, if we take the graph, okay, it correlates somewhere around here. Okay, it correlates somewhere around here, and it is above the suspicious area and very close to the attack area. Okay, that the degree of attack is high in this case, and hence this kind of traffic would be considered as an attack. Okay. Now this is just a graph to showcase you. Okay, this is not visible on the GUI as such. This is just a graph to showcase how this functionality works behind the scenes. Okay, and this is known as a fuzzy logic detection engine, which you are making use of. Okay, so this is what happens in the background. You do not need to worry about this. Everything is taken care automatically for you. Okay, so degree of attack is detected as soon as both of them deviate from their baselines. This is just to explain how the functionality works behind the scenes. But you can certainly visualize the degree of attack on the GUI. So on the GUI, you will be able to see the degree of attack. Okay. So this is what I was talking about. So if both of them would be deviating, in that case, the degree of attack would be high, and therefore it would be considered as an attack traffic. But if only one of the parameters deviate, okay, then it is well within the normal to suspect area. The attack of degree is low, and we are not considering it as an attack traffic. Next phase is the characterization phase. So whenever an attack is detected by the defense pro, the next phase is to create a real-time signature. So the degree of attack is high, an attack has been detected. Now the next thing that the defense pro has to do is to create a real-time signature. So these are all the parameters that are available to us. Okay. There could be more than 40 distinct parameters that a defense pro can make use of in order to come to a real-time signature. So based on the attack traffic, we might be selecting like source IP address, destination IP address, time to live, packet size. These as four parameters, okay, which are matching the attack traffic. And based on these four parameters, we will then be creating a real-time signature. We will then be creating a real-time signature based on these four parameters. Okay. This is known as RTS or real-time signatures, and the attack is for TCP reset. Okay, so we are trying to stop a TCP reset kind of an attack. Okay, and these are the four parameters that we are using in order to mitigate this particular attack traffic, and this is done behind the scenes. Okay, you do not have to select the packets, everything is done behind the scenes. And this is known as footprint. Okay, and this is known as footprint. All the parameters are known as footprint. So in upcoming slides, you might see something like footprint strictness. Okay, footprint strictness you might see. That is nothing but the number of parameters. Okay, the number of parameters within the footprint. Okay, so there are three values: low, medium, and high. These are the three footprint strictness value that you can use. If it is set to low, that means this particular footprint should have at least one parameter. If it is medium, it should have at least two parameters selected. And if it is high, it should have at least three parameters. That means if the footprint strictness is set to high, okay, then this footprint which is generated, it should include at least three parameters. Okay. If it is set to medium, it should have two parameters. And if it is set to low, it should have minimum of one parameter within the real-time signature. So that is your footprint strictness. Okay. So this is done during the characterization phase. We are coming to the real-time signatures, or the defense pro is generating a real-time signature based on the parameters. Next, once this is done, okay, once this is done, the next phase is to attach the uh, footprint or the real-time signature to the attack traffic to mitigate. That happens in the mitigation phase. But before that, I'll just explain this. So whenever an attack is detected, okay, whenever an attack is detected, the defense pro goes into the characterization phase. A initial real-time signature is created at this particular point. So this is the first version of the real-time signature. Now this is created within 10 seconds. Okay. So this is created within the 10 seconds. A initial RTS is created and the mitigation starts from this point, okay, from the 10th second. Okay. But after that, since the characterization and mitigation phases are working together, they constantly check whether this is the best RTS or can we change the parameters in order to get to the best RTS. So they are constantly working and checking whether applying this RTS reduces the degree of attack. Okay, whether it reduces the degree of attack. Okay, and we work with different combination of that parameters, like changing the parameters. Okay, working with different combinations and logical expressions to come to the best RTS. Okay, so initial RTS is created first of all. Okay, the mitigation starts from this point, but for the next 8 seconds, we will check the best combination. Okay, whether this RTS is the best or whether we can come close to the next best RTS. So we are working. Okay, and at the 18th second, at the 18th second, okay, after analyzing all the combinations, we will reach at the final real-time signature, and this is the real-time signature which will then be used to mitigate the attack traffic. So this is your final real-time signature which is uh, created at the 18th second. So even before 18 second, you can still reach the final RTS, depends on the number of parameters learned. Okay. And once this final RTS is created, we will be applying that RTS to the attack traffic. Okay. And the attack would be mitigated by the Defense Pro device. So this is how the flow works. So these are all the clients. Okay. let's suppose an attack is also originating from here. So during the peacetime traffic, okay, this traffic is reaching the statistic engine. It is learning all the traffic statistics. The learning and detection engine are always on. Okay, so these engine are always on. So let's suppose initially there is no attack. During peacetime, the traffic is coming to these engines. Now the statistics engine is learning the traffic statistics, the rate and rate invariant part. That means the learning and detection engine is on. Okay, so this is during peacetime. Okay. Now let's suppose there is an attack started. So now let's suppose there is an attack started. Okay, we are getting attack traffic. So as soon as we get an attack traffic, since the detection engine is on, detection engine identifies that an attack has started. It immediately turns off the learning engine. It immediately turns off the learning engine because we do not want to learn the attack traffic. Okay, so during an attack traffic, the rate part would be very high. The rate invariant part would be showing different flag distribution or incorrect flag distribution. We do not want the DPX to learn that attack traffic, and hence whenever there is an attack detected, we will be turning this learning engine off. Okay, so that's what happens next. So whenever the traffic flows in, okay, so whenever there is an attack, whenever there is an attack detected, the learning phase is turned off. Okay, so the learning phase is turned off, correct? So a degree of attack is high and the attack has been detected by the detection engine. So next process is the characterization phase, which is basically creating your real-time signatures. Okay. So during the characterization phase, we are trying to create real-time signatures. And let's suppose these are the parameters. Okay, these are the parameters that we can make use of in order to create a real-time signature. Okay. Now, instead of using all the parameters, we will only be using those parameters which are relevant to the attack traffic. Okay, so the attack traffic might be coming up with, let's suppose, this destination IP address. It might have a packet size of a certain byte. It could be having a certain time to live. So based on the attack traffic that we are receiving, we will be using only those parameters which are relevant to the attack traffic, and we would be narrowing the filters down. Instead of using all the 20 filters, we would be using 4 to 5 filters. And that's what we do here. So we narrow the filters down to 4 filters. Okay. So this, let's suppose this is the version 1 of the RTS. Okay. Now we'll be working with these 4 filters and trying to find out the best combination in order to mitigate an attack. So that's what we are doing next. Okay. So first we will start with the packet ID. Okay, the degree of attack is low. That means we have gotten a positive feedback from the mitigation part. Next, we also add source IP. Okay, again, the feedback is low. That means it is a good combination. Next, we add packet size as well. Again, the feedback is low. That means we can work with these three parameters. Next, we added time to live. Now, as soon as we added time to live, the degree of attack is now high. Now this is a negative feedback. That means after adding time to live parameter, the degree of attack again became high, which is not what we want. Okay, we want the degree of attack to be low and to mitigate the attack completely. That means time to live is not a good parameter. So we simply remove that parameter and work with these three things, which is packet ID, source IP, and packet size. Okay, and that we consider as the final RTS, and that we consider as the final real-time signature. And this real-time signature is then attached to the attack traffic and pose that the degree of attack would be low. Okay. So we mitigate the attack. Okay, so we mitigate the attack, and after the attack has terminated. So now let's suppose the attacker has stopped the attack. Okay, attack has been completely mitigated. In that case, the detection engine again checks whether the attack has completely stopped. If it sees that the attack has stopped, it will again start the learning phase because now the attack has completely been mitigated and there is no attack coming from any of the public network. So we simply again start the learning process and this flow continues forever. Okay. So this is how the BDOS flow works like and how it creates a real-time signature. Next is the blocking duration. So how the attack starts when we create a real-time signature. So that is explained with this particular graph. So let's suppose an attack has started here. Okay. So an attack has started here. So we are trying to learn the attack traffic and basically trying to create a real-time signature. So at version 1, at the 10th second, at the 10 second, as we know, we will be creating the version 1 of the RTS. Okay. So from this point, the mitigation starts. So from this point onwards, the mitigation starts. Okay. And this is the 18th second where we create the final real-time signature. And post that, the attack is completely mitigated. Okay. So the question would be like, from the attack start to the 10th second, there is no mitigation. You are right, there is no mitigation during the attack start and the 10 second, but we can create a rate limit. Okay. So for the first 10 seconds until the first real-time signature is created, we can rate limit the attack traffic, or we can rate limit the incoming traffic, and this is done here. Okay. So we can rate limit the attack traffic that we are getting using these three things. So we can limit to the normal edge, limit to the suspect edge, or limit to the user defined rate. So as I had shown you yesterday as well, so there are three things: normal edge, suspected edge, and attack edge. Okay. Now, if this rate limiting is set to disable, we will not be doing any rate limit. If we are limiting to the normal edge, that means if the traffic goes above the normal edge, we will be simply doing rate limiting on that particular traffic for the first 10 seconds. After that, the signature mitigation will take over. Okay. And if we set it to suspect to limit to suspect edge, then once the traffic reaches or tries to cross the suspect edge, we will be doing the rate limiting for the first 10 seconds. Okay. So this is how we try to mitigate the attack, and within 18 seconds, we can get complete mitigation. Okay. We will start the mitigation here during the 10 second, and by the 18 second or well before 18 second, we can create the final RTS depending on the combination of parameters. So BDOS protection advantages: it is highly accurate for detecting different types of flooding attacks. It is near real time. So as soon as an attack is detected, we can mitigate them. Okay. It doesn't require ongoing day-to-day maintenance. It doesn't solely rely on rate, because we are looking into different parameters like rate and rate invariant both. Okay. We have very minimal false positive rate. It detects and prevents 0-day attacks, which is very crucial. Okay, new attacks might come in at any point in time, and these attacks can be mitigated uh, well before they cause any disruptions. Okay, so it is great to have this tool. The only disadvantage would be like it requires proper initial configuration. Okay, that means you need to properly tune the BDOS. Okay, you need to properly tune the BDOS and set the bandwidth properly. So these are just the two things that is crucial from initial configuration perspective. That means you need to set the bandwidth properly, tune the BDOS properly. That means the traffic during peacetime should be well below the normal edge that you have set. Okay, if it is above the attack edge, then all the traffic would be considered as an attack traffic, which is not recommended. So only those two things need to be taken care of. Rest, it's a wonderful tool to have, which basically detects and mitigates all kind of volumetric flooding kind of attacks in near real time. So coming to configuration, so this is how we configure the BDOS. Go to policy editor, select the protection module, BDOS protection, enable it. Action would be to block and report. Okay, that means if an attack is detected, you will block it and also generate a detection event. Footprint strictness I had just covered a few slides back. So we have three values: low, medium, high. Okay, basically it specifies the number of parameters within a RTS, number of minimum parameters that it should have. If it is set to low, it should have minimum one parameter. If it is medium, it should have minimum two parameters. And if it is high, it should have minimum three parameters. Now, this is important bandwidth settings. Okay, so whatever traffic that you're receiving or expecting to receive, you need to specify it here under the inbound and outbound traffic. Okay, so this is very crucial. So this is the base upon which the Defense Pro will create the baselines. Okay, the normal, suspect, and attack edges is based on the bandwidth that you specify here. Okay, and the expected traffic, what you can do is that you can analyze your network. Okay, you can see what is the traffic that you're receiving over a period of time, and based on that, you specify the bandwidth there. You can specify 15% more from what you're observing so that it does not create false positives. So you can add 15% more to the bandwidth that you're receiving and just specify it here under both the inbound and outbound traffic. Okay. So this is the first thing that you need to do, set the proper bandwidth here. Next, if you click on advanced, okay, next, if you click on advanced settings, you will see something like this. So here you can see that all the options are selected and which is recommended as well from us because it is protecting you from all kind of flooding attacks, be it SYN flood, UDP, ACT plus finish, okay, reset, ICMP, SYN plus ACT floods, IGMP, fragmentation floods, etc. So it is protecting you from all the flooding kind of attacks. Now let's suppose if you disable this, it will not detect SYN flood attacks, which is not recommended. So keep it enabled as it is. Keep the quota settings default. Okay. Keep the quota settings default. You do not need to modify these things unless and until you want to fine tune the graphs. Okay. Only then you would need to modify this. Otherwise, as a recommendation, keep this quota settings default. Okay. Next, we have transparent optimization. This I'll enable. This I'll let you know what is transparent optimization. Okay. At a later stage, I think there is a separate presentation or a separate slide for this. If it is not, I'll explain it later as well. Transparent optimization. Okay. Packet reporting. So if an attack is detected by the BDOS, okay, it will create a packet capture file for you, which you can open in the Wireshark. So that is your packet capture settings. So these are some things that you need to do on the advanced parameter. Now, BDOS quota. So bandwidth, there are two things. First of all is bandwidth settings, and second is the quota settings. Now, bandwidth settings are important because based on this, we create the baselines, which is normal, suspect, and attack edge. Quota settings is used to increase or decrease the gap. Okay, so I'll just draw and explain this. So yesterday we saw the graph, right? Normal, suspect, and attack edge. So these are the three edges. Okay. So this bandwidth is very crucial because based on the bandwidth that you set, we will generate this baselines. Okay. Now, if we increase the bandwidth at a later stage, so let's suppose this is the graph at the moment. If we increase the bandwidth, what we basically do is that we take these three lines and we move them up. So we move them up. So we increase the bandwidth, those three lines will come somewhere there in here in the graph. Okay, so that is increasing the bandwidth. Decreasing the bandwidth works in opposite direction. That means those three lines will come below. Okay, of what was initially configured. So that is increasing or decreasing the bandwidth. Now, quota settings. Now, let's suppose if we increase the quota. Okay, so if we increase the quota values, then what this does is that the graphs remain as it is, but what we are doing is increasing the separation. Okay, so now let's suppose this was the initial difference between the two. Now what we do is that we increase the separation. So it will look something like this now. Okay, so the gap between the three lines increases. So that is increasing the quota levels. Okay. So that is the two things that we need to be aware of when we are fine tuning the graphs, which is important. I'll explain during the tuning presentation that why it is important and how we can do that. Quota settings, keep it as default as a recommendation. Do not change it unless and until you need to do fine tuning. Okay. Then we have burst attack protection. So this is important. So let's suppose there is a burst kind of attacks. So let's suppose there is a burst kind of attacks. So first attack started here. Okay. First attack started here. We created a real-time signature and the attack stopped at this particular point. Okay. So let's suppose attack started here. We created a real-time signature and the attack stopped. If we have enabled burst attack protection, if we have enabled burst attack protection, we remember the RTS which was created, okay, in order to stop this particular attack. So we remember the RTS that we have created in order to stop this attack. So let's suppose this attack again started, okay, within certain minutes. So after few minutes, the attack again started. Since we have this RTS in memory, we do not need to learn the RTS again. We can simply attach this RTS right away and we will mitigate it much faster. Okay. So if there is burst kind of attack, that means the attacker is attacking, stopping for a few minutes and again starting the same attack, then it can be mitigated without the defense pro having to learn the RTS again and again. We can remember the RTS in the memory and that same RTS can be used to mitigate this burst kind of attacks, and maximum interval between the burst can be specified here under this particular tab. Okay. Then we have learning suppression threshold as well. So let's suppose there is uh, so let's suppose learning suppression threshold, what it means is that we are not over learning. Okay, so we are not over learning during any process. Okay, so let's suppose we are receiving the traffic and suddenly the traffic increased. Okay, if it increases more than 25%, we will not learn that particular traffic. Okay, because it could be an attack and hence we are not learning more traffic. Okay, so that is your learning suppression threshold. So with that, we conclude this part of the presentation. Any doubts here? Okay. So if there are no doubts, let's take a 10 minutes break and then we can continue with the rest of the presentations for today. Okay.
Okay.
Perfect. So welcome back. Let's resume with the presentations. So the next topic is related to behavioral DOS, protection monitoring. So here we'll be looking at the monitoring aspect of the behavioral DOS engine. So how to check the real-time traffic statistics. So of the BDOS, so you have to go to Defense Pro. Okay. So go to the Defense Pro page, click on this icon of protection monitoring. Under the BDOS traffic monitoring reports, you can visualize the traffic statistics of the learned parameters. So this is what you will see if you go to the BDOS traffic monitoring reports. So this is your statistics. So this is the legitimate traffic that is learned during peacetime. Okay. And this is the data that you will see. So this is the real-time traffic statistics or the real-time legitimate traffic that you're receiving. And these are the three edges. Okay. These are the three edges: normal, suspect, and the attack edges. Okay. And this is created based on the bandwidth that you set, but this is the legitimate traffic. Now, in this case, the legitimate traffic is closer to the normal baseline, which is okay. And this looks like a good traffic to us because it is well within the normal edge. Okay, it is not going above the normal edge for a large duration of time, and it is not even closer to the attack edge, which is good from tuning point of view. In this case, we do not have to tune this particular graph. Okay, so this is a good representation of how your traffic should look like. Okay. Now, whenever we use quota, it is basically increasing the gap between these lines. Okay. If we increase the quota, we'll increase the gap between the lines. If we increase the bandwidth, we will move the edges above. Okay. Now, if the legitimate traffic was above this, then it will classify even legitimate traffic as an attack traffic, and hence we do not want that to happen. Okay. And that's why we need tuning process, which we'll be covering in the next set of presentations. But as of now, this is just to showcase where you can see these details and where you should go. So this is where you will go in order to visualize these things. And here you can only see one graph at a time. Here you can only visualize one graph. So right now it is showing for TCP SYN. So if you want to check for TCP reset, you will have to drop down and select the relevant traffic type that you want to see. And then the graph of that particular traffic type will open up for you. But right now on the Defense Pro, you can visualize only one graph. On the cyber controller, you can visualize all the graph together in one place. You can see the attack status here as well. So if it is normal, that means it is properly tuned. In case of an attack, it will show up as under attack. Okay. If we go to this last sample statistics, you will see the degree of attack. If the degree of attack is high, then there is certainly an attack being detected. You can also see the rate and rate invariant part. If both of them are very high, it basically correlates that your degree of attack would also be high. In that case, it would be classified as an attack traffic. Now this, as you can see, the attack status is showing footprint blocking. That means you now have an attack. If you see the graphs, these are the three graphs, okay? The graphs are somewhere here, normal, suspect, and attack edges. But the traffic that we are receiving is well above all the three edges. That means there is certainly an attack being detected, okay? Because these thresholds have been breached and the rate is very high, and hence we are classifying this as an attack. And here the attack has started and we are mitigating it. And the same you can see here as well. The degree of attack is very high. And this is a TCP SYN kind of flooding attack happening. And whenever there is an attack detected on the cyber controller, you will see this that it is under attack. Okay. Uh, this is your received traffic. The received traffic will be blue in color. So if you see, this is the received traffic that you're getting, including both legitimate traffic and the attack traffic. And this in maroon or red, okay, would be your drop traffic. Okay. So this would be your drop traffic, and this is dropped by the policy. Okay. The attack has been detected and the attack traffic is getting dropped by the defense pro. And this is the detection event stating that the attack was detected by the behavioral DOS engine. Okay. And the defense pro is dropping the traffic. The attack is still ongoing. That means the attack has not stopped. It is still ongoing. Okay. And it has been ongoing since the last 7.5 minutes. And it is targeting this particular destination. And it is a flooding kind of a network attack. And the policy which is kicking in is this particular policy which you see here, which is currently active. And whenever there is an attack and the policy is triggered, you will find this icon. Okay. It simply means that an attack has been detected and it is getting mitigated by this particular policy. If you want more details, you can click on this and then you will find this page where you can, after some time, these things pop up. Okay, initially you might not see these graphs, but over a period of time, like after 18 seconds or so, you will find these details. Okay, if you click on this red dot, if you click on this red dot, you will find the real-time signatures that is being used. Okay, you will be able to see the real-time signature. Also, you can see the real-time signature here as well. So these are the real-time signatures being used, and these are the parameters used in order to mitigate this particular attack. Okay. Here you can see the physical port on which the attack has started. Okay. The action taken is drop the package. The in direction is incoming, so that the packet is received on port number 1. We have associated a Radware ID to it. The risk is a very high category. The source port is this port. Okay. And we are basically blocking that particular traffic. And this is the amount of packets that we are receiving during the attack. If you click here, you will be able to download the packet capture, which you can use on the Wireshark or open on the Wireshark to see the actual traffic flow. And then if you click on attack analytics, you will find all these details, like whether it is a multi-source attack or it is coming from a single source, which destination it is targeting, whether it is targeting multiple IP addresses or just a single server, okay, which source port is being used, okay, which destination port it is targeting, where the traffic is originating from, okay, how much traffic is are we receiving from those individual sources, okay, what is the packet size distribution, okay, of the attack traffic, okay, which protocol is being used to target the attack, what is the TCP flag distribution. So all those things you can get via attack analytics page. Attack details with footprint. So here is an example that BDOS can change the signature since the attack is changed. Now, if the attack has changed, the BDOS can detect that as well and change the attack or the signatures. So let's suppose in this example, okay, in this example, the message type has been changed. Okay. So here the message type is 13, but the attacker modified a certain parameter to launch a different kind of an attack that was detected by the BDOS engine, and the new real-time signature was created, modifying the message type as 8. Okay. Rest everything remains the same. The attacker on even this part, okay, package size. So even these two parts were changed by the attacker. We detected that in near real time, and we also changed the signature to make those modifications so that we can mitigate the attack. So this can also be done by the Defense Pro in near real time. You do not have to do this manually. This is what I was talking about related to the cyber controller. We can visualize all the graphs together in one go so that we can look at the graphs and make modifications accordingly. So on this particular cyber controller page, you can visualize all the graphs together in one place. Like for this case, we need to perform some kind of tuning because it is going above normal edge. Okay. And this is okay because it lies well below the normal edge. So you can visualize for which particular graph, what is the actual scenario now. And based on that, we can make certain modifications on the tuning part. So with that, we conclude the monitoring aspect of things. The next topic is related to BDOS tuning. Okay, so let's have a look at that.
Rohit, I have a
Yes.
question.
Yes, go on.
Uh, could you please a little bit explain about learning separation threshold, UDP packet rate detection sensitivity, and our blocking settings?
Can I take it later, maybe?
Yeah, sure,
Just
sure. Okay,
let me remind because it was in the last presentation, if I'm not wrong. Just let me remind me after the end of the presentation. I can take it up later. Okay.
okay, thank you.
The learning threshold and suppression threshold, right?
Learning suppression threshold,
Learning.
packet
I'll just
rate
type it in the
detection.
chat so that I
Yeah,
can
okay,
remember at a later stage. Learning suppression threshold, and if I'm not wrong, it's overblocking, right?
I will send.
This is right.
Yeah.
I have already typed in the chat. Okay.
Okay, okay.
Just
Give me
remind me in
one
case I
second.
forget. Sure.
Sure.
I'll take it up later. Perfect. So let's continue with the tuning aspect for now. So behavioral DOS tuning. So the next step is this. So here we'll be understanding what we need to change, okay, respective to the graphs that we observe. First is environment assessment, initial configuration tuning. So environment assessment would be to identify what we need to configure on the Defense Pro before we do any initial configurations, like what are the types of attacks that you might face, what is the protected object, like which is the network that you're protecting, what kind of protections you would need, okay, how much time are you gonna send the traffic, etc., etc. So initial assessment is basically trying to understand what is your network, how does it look like, which network we have to protect, what kind of protection, which kind of servers are there behind the backend. Okay, what kind of protections are we going to enable for those servers, whether we need signature-based protection, whether we need a ERT service premium, etc. So we do an environment assessment initially to identify what are our goals and what we need to enable or configure on the Defense Pro. That is done under environment assessment. Next is initial configuration, where we primarily need to set uh, the bandwidth. Like for BDOS, we need to do the initial configuration of the bandwidth settings. We need to identify how much amount of traffic that we are gonna expect. Okay, based on that, we, let's suppose, increment in the 15% more than what we are expecting. We configure it at the BDOS engine. Okay, so those are the initial configurations that you can think of. Once that's done, okay, then we will check the graphs whether the peacetime traffic is well below that particular normal edge. And if it is not, we need to do tuning. Okay. So initial configuration is important. Setting up the bandwidth is important. And post that, if still the graphs that you see in that graphs, if the peacetime traffic is above the suspected edge or closer to the attack edge, then we need to do the fine tuning, which is what we are going to talk about in this presentation. Okay. So before that, some recommendations. Learning period should be at least 1 week. So it enables a defense pro to learn the traffic patterns in the environment during peacetime. Okay. So during peacetime, the defense pro would be able to learn the traffic, all the characteristics, all the statistics. Okay. And here, during peacetime, we'll be learning all the traffic parameters. The goal is to create a normal baseline based on the real traffic. Okay. So whatever we are learning during this peacetime, based on that, the graphs would be created automatically. Okay. And if the graphs are not proper, then we need to fine tune it. How we can check if the fine tuning is required? There is a command on the CLI that you can use, which is DP behavioral DOS global advanced check baselines. So if you run this command, you might get certain recommendations from the CLI that the normal baseline is too close to the attack threshold. Okay. So these kind of notifications you can get. Okay. And it also shows you that it is for UDP, IPv4, etc. So then you can basically modify certain things and do the fine tuning accordingly. So this is one command which can help you. Even just looking at the graphs, you can identify whether the tuning is required. Okay. And you will be able to answer very quickly that whether it is a good graph or whether it is a bad graph, which I'll show you, and you will be answering it on your own without even looking at the CLI. You can answer those things. Okay. So how to tune? So there are three steps that you can do. Okay. Either you can increase the bandwidth. Okay. Increasing the bandwidth will basically increase or basically move the lines up. So there are three edges, right? Normal edge, suspect edge, and attack edge. Increasing the bandwidth will basically move those three edges up or down. Okay. Increasing the bandwidth will move it up. Decreasing the bandwidth will move it down. So that's the bandwidth settings. If we increase the quota, it will just increase the separation between the lines or the gap between the lines. So that is increasing the quota. Decreasing the quota will decrease the gap. Okay. So these three things are important and it is configurable under the BDOS setting. So increasing the bandwidth, you will be doing it here. Okay, increasing the bandwidth, you will be doing it here. Okay, and increasing the quota or decreasing the quota, you will be doing here under the advanced settings. So let's have a look. So this you need to answer. Okay, so as per the graph that you can see, do we require tuning in this or whether we do not require? So this is the normal edge. Okay, this is a suspected edge and this is the attack edge. Okay, so and this is the peacetime traffic or legitimate traffic that we are receiving at the moment. So do you think you will require tuning in this case? This is a question. Okay, so you will have to answer before I proceed. So any one of you can give a try. So Yusuf has said yes, we require tuning. So Yusuf, can you explain the
Yes,
reasoning
it's
behind it?
required tuning. It's required tuning.
Yeah.
Yeah, hello everyone. Yeah, I see that the traffic is reaching the suspect edge, which will
Yeah.
create false positives, something which we
Correct.
don't want. So for me, I would prefer to fine tune it to increase the gap between them, so avoid the false positives.
Absolutely spot on. So here we require fine tuning, and it is a bad kind of configuration. So absolutely spot on. And yes, even Dio has agreed, which is great. So here, this is a bad kind of configuration. So we here need to change the attack and suspect edges. So basically, we can either increase the bandwidth, okay? Either we can increase the bandwidth so that the normal edge, the suspect edge, and the attack edge moves above, okay? We can increase the bandwidth so that we can move the edges above. So the normal edge would be somewhere here, the suspected edge would be here, and the attack edge would be here. So we do require a fine tuning in this case. What about this?
It's good.
Uh, yes, it is good. Correct answer. So it is good kind of a configuration because it is closer to the normal edges, and even
Yeah.
only during certain time it is going above the normal edge, and it is nowhere close to the suspect edge. So this is a good configuration because your legitimate traffic is very close to the normal edge. Okay. Uh, I would like someone else to answer the next question. Okay. So what about this? So this is a legitimate traffic, okay, which you see on the, oh, sorry. So that is a legitimate traffic that you see up on the top. Okay, so this is a legitimate traffic and these are the three edges. So what do you think about this graph? So what do you think about this graph? Good, bad, very bad, worse?
It's very bad. We have to increase the normal rate.
Yeah, you're spot on. You're spot on. So this is a very bad kind of a situation where you have basically at the initial settings, you have configured the bandwidth very low. Okay. And the actual traffic that you're receiving is very high. Okay. So this is actual traffic that you're receiving, but the bandwidth configured on the BDOS is very low, somewhere close to this, and hence you're getting this kind of a graph. Now we need to fine tune it. So basically we will be increasing the bandwidth so that these three lines will be somewhere closer to here and the received traffic is well below the normal or closer to the normal edge. So this is what we need to do in this case. We need to increase the bandwidth.
In this case, the traffic is dropped.
Sorry, what? Yes, it will be. It would be dropped because it is
Okay.
above the attack edge.
Okay.
Yep. The next is this. Okay. So the next is this. So this is the normal edge. This is the suspected edge, and this is the attack edge. Okay. So this is the peacetime traffic that we're getting. But what we did is that it was above the normal edge, which is not something that we want to happen. So what we did at this point is that we increased the bandwidth. Okay. At this particular point, we increased the bandwidth so that the normal baseline has moved up to here. Okay. So now the normal edge is here, suspect is here, attack is here. So we basically have increased the bandwidth. So the graph has moved up, okay, and the traffic is well below the normal edge now. So after doing the configurations or doing the fine tuning, after fine tuning it, it is normal. But before that, it was a bad kind of configuration. But after fine tuning, it is good. So tuning a UDP only environment. So if it is UDP, you can make use of these settings. So you can make modifications here in order to tune the UDP settings. Footprint strictness I've already covered, so not covering it again. So these are the parameters that we need to sort it out. One more thing when it comes to footprint strictness is this. So let's suppose if you have set the footprint strictness to high. Okay, so let's suppose you have set it to high. So the minimum requirement would be 3 parameters. So let's suppose the attack is running only on 2 parameters and we are unable to find 3 parameters. Okay. In that case, the attack would be allowed to pass through. It will not block the attack because the minimum number of parameters that we require is 3. But the attack is running only on 2 parameters and hence we are not able to find those 3 parameters. The attack would be simply be passed through. Okay. So in that case, we might have to change the footprint strictness back to, let's suppose, medium so that it can work with 2 parameters. Okay. So that is one thing that you need to be aware of. During such scenarios, it will shows as non-footprint strictness. Okay. So on the attack characteristic during the detection event, it will show non-footprint strictness in that case. Uh, which is exactly this I was talking about. So it will show something like this, non-strict footprint, if we are unable to find the number of parameters. Okay. And in that case, it will simply forward the traffic to the backend without dropping anything. So that is a risk. So if that's the scenario, if you find something like this, just change the footprint strictness to low or medium in that case. So after changing the strictness to medium, Defense Pro again starts to block the attack. Okay. So that was all about fine tuning as well. Let's go at the Defense Pro DNS protection now. So DNS, if you have DNS servers to protect, then you will be using DNS server protection. So how the DNS works, how we can protect DNS servers against threats and vulnerabilities is something that we'll be covering under DNS protection. So how DNS works, it is very simple, as you all know, not going much into depth here, but it is basically translating your domain names into IP addresses so that the computer can understand it. So basically, if you're sending any request to a target domain, that domain name would be resolved to IP addresses, okay, something like this, and then the computer can directly target that particular IP address for that particular domain name, and it would be provided to your PC. It is similar to a phone book. So just like a phone book has multiple chain of events like this. Okay. Similarly, the DNS will have a domain name, the root zone, the top level domains, the second top level domains, etc. So similar to a phone book, you also have the DNS classified as this. Since you're already aware of all these things, not going deep into it, this is important. A type of DNS servers. There are two types of DNS servers available, which is authoritative name server, okay, and the recursive name servers. So these two are important. Recursive name servers and authoritative name servers. Authoritative name servers are the actual owners of the domain, okay, so they will have the actual record, but the recursive name server is present at the ISP end. So the recursive DNS server is present at the ISP end, and authoritative name server is basically your actual owner of that particular domain name. With that in mind, let's continue. So the user will send a request, let's suppose www.radware.org, okay, within the browser. As soon as the user enters this particular URL in the browser, it will check its local cache whether the domain name was initially translated or not. If it is not, it will send out, okay, it will send the DNS request to the upstream DNS server. Okay. Now this recursive DNS server will check in its cache whether previously I have resolved this particular domain name or not, or whether do I have the IP address resolution for this domain name. Okay. So that's the first process. It will check in its cache. If it is not present in the cache, recursive DNS server will forward it to the authoritative name server. Then authoritative name server needs to check whether this domain name is present with me, and if it is present, it will send out the IP address details. Okay, that detail would be stored in the cache first of all, and then it will be forwarded to the user. Then the user can directly request that particular IP address directly. So this is how the DNS server works. So here we have two kind of DNS servers: authoritative DNS server and the recursive DNS server. Recursive DNS servers is present at the ISPN. Okay, so here we will be sending a request. Okay, if it is present in the cache, it will answer it directly. If it is not present in the cache, it will forward it to the upstream DNS server to ask for that resolution. And this act of recursive DNS servers can be manipulated by the attackers. Okay, which I'll show you how that happens. But this is how the DNS system works. Okay. So if it is present in the cache, it will reply directly. If it is not present in the cache, it will forward to the upstream DNS server from wherever it can get that particular uh, response. So recursive DNS server is present with the ISPs or large scale carrier providers. Authoritative name server is the actual owner of that particular domain name. Now, DNS is a critical infrastructure because no DNS basically translates to no service, because websites, they are identified by their domain names. No one these days actually remember what is the actual IP address to that particular domain name. There will be tens and thousands of websites, and each one might have a different IP address resolution. So it is impossible to remember all the websites by their IP addresses, right? So DNS becomes very crucial. So let's suppose if the website is up, but the DNS infrastructure is down, okay, the website might still be accessible via IP address, but it might not be available via, let's suppose, domain names. In that case also, the website is up, but you're still not able to reach them via domain names, and it is a critical uh, service in today's day and time, and hence no DNS basically translates to no service. And hackers are using this DNS capability to launch various attacks. So you can see that the application level DNS flooding attacks has increased considerably. So this is from 2022 to 23, where we saw an increase of up to 394% in when it comes to DNS flooding kind of attacks, okay, targeting all the DNS servers because they understood that DNS is one of the critical infrastructure. If it is down, that means the service interruptions are very evident. So application level DNS floods is something that we need to stop at the base level. So let's look at one of the attack types, which is recursive attack. Okay. So here what we're doing is that the attacker is sending random queries. Okay. So the attacker will be sending random queries. So this is the actual domain name, let's suppose. Okay. In front of that, we are just putting some random integers, random numbers, random alphabets. So these are basically fake requests or fake domain names, fake request or fake domain names that the attacker is forwarding to the ISP servers. Now, if you remember the working of the ISP server, so what is the function? If it receives a request, it will check whether it is present in the cache. Okay. Now, these three are fake requests. So that means the resolution will not be present in the cache, right? So what does the open resolvers do? They simply forward it to the upstream DNS servers. Okay, since it does not exist in the cache because these are fake requests that will not be present anywhere. So it will forward it to the upstream. Okay, that will forward to the upstream, which basically the CPU and memory utilization of the ISP and the authoritative DNS servers will all be targeted at once because these are fake requests and does not exist anywhere. The authoritative DNS servers can still handle these requests by dropping because they can configure an allow list because they will be handling very less amount of websites. Like let's suppose 3 or 4 websites the authoritative name servers would be handling, and they can configure allow list, okay, because they do not need to check other domain names like ISP resolvers, right? So for authoritative DNS server, it is still okay. They can manage these kind of attacks. But when it comes to ISP resolvers, it becomes very difficult for them, right? Because their role is to basically translate all the domains that they get, whether fake or whether legitimate. Okay. So that is something that the ISP resolvers need to handle, and it has become a huge task. So that's where our automatic engine helps, wherein they can learn the legitimate traffic and illegitimate traffic using AI, which I'll discuss later. But this is one of the top attack vectors where the attacker is basically sending out spoofed query request. Okay. So they are basically sending out spoofed query floods like these, which does not exist anywhere in order to consume the CPU and memory of the resolvers. This is exactly the same again. So we are basically sending a large number of requests towards the. Now this might be a legitimate request as well. These might be legitimate requests, but we are sending a lot of requests in a single go, again, leading to flooding of the request towards the targeted domain or the targeted ISP resolver. So we are sending a lot of requests, and this amount is not processed by the server because server might have a limitation that these are the amount of requests that I can handle. If that threshold is breached, that means the DNS server would be down, and hence all, even if the legitimate user is trying to access the resource, they will not be able to do it because we are spending a lot of time and effort on the request which are being sent by the attacker. Even if they are legitimate, the main goal of the attacker is basically to bring down the DNS server. So there might be flooding attacks as well. Again, we can spoof the source IP as well. So spoofing the source IPs, we can send out large number of traffic from multiple sources all in once, leading to amplification of the attack towards a targeted DNS server. Basically, the main goal again is to bring down the DNS servers. So existing DNS protections are no longer enough. We have already seen an increase in the number of DNS flooding attacks. And remember, it was in 2023. Now it will be even more. So we need to protect the DNS servers as well. The attack sophistication has increased. They are using multi-vector randomized attacks. And even with the advent of AI and machine learning, they can make use of different tools which are readily available. Okay, they will be able to launch attacks from minimal resources. So the attack sophistication has increased. The rule-based protections are no longer enough. We need an AI approach in order to tackle all these things, and that's where Defense Pro DNS protection comes in to tackle all this. So we are using AI-powered DNS security for zero-day DNS DDoS attacks in order to mitigate them. So Defense Pro DNS protection, we make use of multi-vector protection. Okay, we are not just using a single protection mechanism to stop DNS DDoS attacks. We are making use of multiple protection modules. So the first one is the allow list. So this is used to stop DNS water torture attacks, or basically the recursive DNS kind of attacks, which we already discussed. So recursive DNS attacks, we are sending a large amount of fake request to the ISP resolvers, and with the help of scoped allow list, we can basically mitigate these kind of attacks. So when we are sending fake request, okay, we can make use of AI engine to identify whether the request that we are sending is a legitimate request or a fake request. Okay. And if it is a fake request, we will be simply blocking it here. So an allow list is created in near real time based on the learning. So we will learn the input. Okay. We will identify whether it is a legitimate traffic or whether it is a fake request. And based on that, we will simply be dropping that particular illegitimate request right at the perimeter. Okay, we do not allow those requests to go through. Okay, so that is the first one, scoped allow list, wherein we are blocking or mitigating DNS water torture or recursive DNS kind of attacks. Next is the query flooding kind of attacks, where these might be legitimate requests. Okay, where these might be legitimate requests, but they are sent in very high rate. Okay, a large number of requests we are getting in very short time. Okay, normally a user will be sending a DNS request like once in a while. Okay, like you might not be getting, like, let's suppose 10,000 requests in 1 second. So that is something problematic. Okay, so these are legitimate, right? They are targeting a domain name, or they're using the domain name which exists. They're not spoofing anything, or they are not sending fake requests. These are all legitimate requests, but the rate of these requests that are being sent is very high, and hence these are known as query flood kind of attacks. Okay, so how to mitigate these attacks? This is where the BDOS is used. Okay, so this is where your BDOS engine is used. So behavioral DOS protection is used in order to mitigate DNS flooding kind of attacks. So here, what we are learning is we are not learning the number of SYN packets or the percentage of SYN packets. Here, we are learning query rate. Okay, so how much queries are we receiving, and what is the percentage of that query rate, or the percentage of, let's suppose, a record with respect to other records, etc. So that is what we are learning in BDOS for DNS protection. Okay. So again, based on all those parameters, whenever we generate a query flooding attack, a real-time signature is created, and the rest of the things remain the same, similar to what we saw in the previous presentations related to BDOS. So all those things are relative here as well. Only what we learn is different. So query floods are mitigated using BDOS engine. Next, we have name server challenge. Now, this is a challenge response mechanism that we are using. So this is the challenge response mechanism. I'll just write CR, okay? Challenge response mechanism that we are using. Now this is used to stop spoofed query flooding attacks. So here it was coming from a source, a single source, which is not spoofed, okay? But here we are using spoofed IP addresses, okay? So we might be using multiple clients, and we are getting these attacks from these spoofed IP addresses, okay? Query flooding attacks from multiple sources. So how we can mitigate this? So whenever we detect an attack of these type, okay, we are basically challenging that particular client. Okay, so whenever an attack starts, we challenge that client. Okay, if we do not get a response back, we simply block that particular client. Okay, we do not allow rest of the transaction to happen. We simply block that particular attack. So this is challenge response mechanism. Now this is only applicable to authoritative name servers. Okay, so this is only applicable for protecting authoritative name server. It is not applicable for recursive DNS servers. Okay, only for authoritative. Next, we have abnormal source FQDN repetitions. So let's suppose if you are receiving a request from the same source, okay, for a particular domain name, okay, like let's suppose it is normal that you receive 10 requests, let's suppose, from a same source. But if you're receiving like 500 or 10,000 requests per second, okay, from a single source, then that is abnormal activity. So that's where you can rate limit those kind of requests as well. And that is what adaptive source FQDN rate limit means, which is coming from a normal client, okay, or from botnets as well. So if it is coming from a normal client, but we are getting a large number of requests, then we can also rate limit as well. Okay. So these are the four things. Scoped allow list, which basically eliminates recursive DNS kind of attacks, blocking illegitimate or fake requests. Next is the BDOS engine, which protects you against query flooding kind of attacks. Third is name server challenge, which is applicable only for authoritative name servers. Fourth is rate limiting, okay, which protects you again non-spoofing or DNS botnet kind of attacks. And post going through all this, we will get a clean traffic. Either one of the functions will help you out eventually. So these are the defense layers when it comes to DNS protection. So this is how we mitigate a DNS water torture kind of attacks. So let's suppose these are the requests that we are getting in real time. Okay. And we have configured, let's suppose allow list. We have enabled allow list on the DNS. Okay, and these are the DNS servers that we are protecting at the backend. Okay, let's suppose this is a recursive DNS server and we have configured allow list here. And we're getting a lot of requests. Few might be legitimate and few are water torture attacks, which are basically sending illegitimate requests as well. So we are checking for this example.com, which is the domain name which is present here. Okay, so these are legitimate domain names which exist at the backend. Okay, and if you're receiving a lot of illegitimate requests, something like these, this can be automatically be detected by the Defense Pro based on the AI engine. Okay, it will automatically detect that this is something that is not present at the backend because I'm not getting any response. Okay, for these kind of requests, just simply block them. Okay. So we are blocking those kind of requests and categorizing them as this. So allow list helps us to basically block the illegitimate requests and only allow legitimate requests to go to the backend DNS servers. So allow list, there are two methods to configure allow list. You can manually upload, okay, or you can automatically learn as well. So this is a preferred one where we can automatically learn the IP addresses or basically the domain name entries. So basically learn the domain name entries automatically using AI. Okay. At max, you can learn up to 10 million entries and which is 1,000 times more than the competition. Similarly, if you are uploading the entries manually, you can have up to 5 million entries, which is again 500 times more than the competition. Now, allow list anti-poisoning. So this is something related to the learning phase. Okay, this is something which is related to the learning phase of the DNS. So during initial configuration, so let's suppose when we start the DNS protection, we will be seeing a lot of unrecognized pattern. So UPS is your unrecognized pattern samples. Okay. So what is unrecognized pattern? So when we start the protection, every domain name that you receive is not known to us, right? It's not known to the defense group. That means it is unrecognized. So during initial operation or when we start the defense pro, mostly all the domain names are unrecognized. So we will start off with a high rate of unrecognized pattern per sample. But over a period of time, since these domain names are requested time after time again, okay, so the number of unrecognized patterns go on decreasing, okay, because we are getting those requests time and time again, and very few domain names we are getting that are new to us. Okay, so this unrecognized pattern goes on decreasing, and over a period of time, it settled down. And over a period of time, it settles down within these two uh, lines. Okay, it might be the peacetime threshold that we see. Okay, but one fine day suddenly the rate of unrecognized pattern increases and it crosses this threshold. Okay, it is a sudden increase. Okay, this primarily is an attack happening. Okay, this primarily is an attack because it was stable over a period of time. We are not facing any new domain names towards the backend servers, but right now we see that there are a lot of requests coming in. So when this happens, whenever an attack is detected and if it crosses this threshold, we are basically stopping the learning. Okay, similar to what we saw in the BDOS engine as well. Whenever an attack is detected, the learning is stopped. So this is what we do it here as well. So whenever the number of unrecognized pattern sample increases, and if it crosses the threshold, we will stop the learning here. Okay, we'll stop the learning, and only once it gets below this, we will start learning again. Okay, this part we will not be learning anything, and this is known as anti-poisoning. We do not want the system to learn illegitimate request. Okay, now how to import the allow list. So you can go to the scheduler task on the cyber controller. You can select task type as allow and block list. Subtype would be DNS allow list. You can run the schedule daily or whatever time you prefer. You can change it this as well. Okay. So that is DNS allow list, how to import from the DNS allow list. You can set manual entries as well if needed. So manual entries you can enter. Okay. A remote server settings is something like this. From a target DNS server, you can import the settings. Okay, you can import the settings from this particular server. So on this server, you might have all the domain name allow list entries. From that, you can import it. So that you can import it from this particular DNS server. So you need to specify the IP address. Then we have DNS handling. So this is important from the exam point of view as well. Okay. So there you will be asked to set a manual entry for www.radware.com. Okay. So you need to set a manual entry. Okay. So that's where DNS handling comes in. So DNS handling, if you export all entries, you will see the list of all the allow listed domains. Okay. And if you select manual entries, you will only see the manually entered entries that are allowed. Auto learned entries will basically show the entries which were learned automatically. If you want to delete the entries, you can delete it from here. Behavioral engine, I'm not going much into this because this is already covered previously. Everything remains the same like for the BDOS engine. Only the learning phase is different. Here we are learning the query rate. Okay. So how many packets are we receiving per second? But here we are learning how many query rates we are receiving. So that's the only difference. Rest everything remains the same, like creating a real-time signature, attaching it to the attack traffic, etc. Next is the name server challenge. Now this is applicable only for authoritative name server. Okay, and this is a challenge response mechanism where we are challenging the client and they need to perform the challenge and send us an appropriate response. Only if we get a response, we'll be allowing the traffic to pass through to the actual name server. So it works something like this. So let's suppose the client is requesting for example.com. It reaches the ISP resolver. Okay. The ISP resolver forwards that request to the DP, which is Defense Pro, and the actual name server is sitting behind the Defense Pro. Defense Pro is protecting this name server. Okay. Or the authoritative name server in this case. So when this client request reaches Defense Pro, what Defense Pro does is that it sends back, okay, it sends back a response. Within the response, we specify a cookie and the actual domain. Okay, so we send a response back sending that this is the cookie that I've inserted and this is the domain name. So now when this response reaches the resolver sends if the resolver replies with this particular cookie, okay, if the resolver, which is this part, it replies or basically asks for the same domain with the cookie inside it, that means this is a legitimate source. Okay, because if it was not a legitimate source, it will not be sending back the response with the cookie, because usually whenever the attacker attacks, okay, he's just sending out queries after queries without checking the responses. He will just send out queries after queries. He will never be looking at the response which is coming from the other side. Okay, so that is your spoofed query flooding attack, right? So here, if we are getting a proper response back from the source, it means that it is a legitimate source. Okay, so now the Defense Pro at this particular point categorizes that this resolver is a legit source, and hence now I can supply the actual name server details to that resolver. So now the Defense Pro sends the response back stating that this is the IP of the real name server that you need to go to in order to get this. Okay. So now the request will directly go from the resolver to the name server, and the name server can then respond with the IP address of that domain name. So this is how the name server challenge works, which basically eliminates spoofed requests. Okay. Now the important thing here is the resolver might use different IP addresses in order to resolve these domain names. But importantly, these two IP addresses must be in the same subnet or within /20 subnet. So that's the only requirement, and usually it is the case. Okay. So those two IP addresses must be in the same /20 subnet or maximum up to /20. Next is adaptive rate limit. So this is just rate limiting the normal sources. So if these are non-spoofed sources which are coming and they are asking a lot of request for a target domain, in that case we can also perform rate limit on those particular sources. Okay, and this is should be the last resolve action. If none of the other functionalities work, then you can certainly do the rate limiting on those sources. So these are the four things when it comes to DNS protection. It is not just a single source of protection. We have multiple sources and each one of them are handling different tasks. Okay. And the settings can be configured here. So under the policies, you need to enable DNS flood protection. Okay. Configure the type of server that you're protecting, whether it is authoritative or whether it is a DNS kind, sorry, the recursive type of server that you need to specify. You need to specify the maximum allowed query per second. Similar to what we did for BDOS. In BDOS, we were specifying bandwidth. Here we'll be specifying the maximum allowed query per second and the expected rate as well. Expected rate would be something that you're expecting, and maximum allowed is the, let's suppose 500 is the maximum the DNS server can handle. So that amount of requests you can specify here, and the actual expected query rate you can specify here. So those things need to be configured. Under the advanced settings, again, you need to configure these things, which is the quota settings again. Same things you can also perform on the Defense Pro page as well. The previous page was related to Cyber Controller. On the DNS protection, also on the Defense Pro, you can perform these configurations under the settings option, protections, DNS flood protection profile, etc. So here we need to just specify the query quota. By default, you can keep it on default. Under the Defense Pro, there is a new licensing scheme, okay, which is related to security operations. So this is the new dashboard which is available on the Cyber Controller if you have purchased Cyber Controller X license. So these are the new dashboards that you can see where we can visualize if an attack has happened, which mode of operation has been used, whether it was challenge response, whether BDOS was being used, or whether allow list kicked in. So any of those things can be shown here based on the sequence. Important thing when it comes to application protection subscription. Okay. Here, primarily we'll be, in order to protect DNS servers, we'll be using application protection subscription. Okay. Now, before version 10.5, DNS protection, as you know, was part of the base license, but after 10.5, it has moved to the application protection subscription. So you need to be aware of that. So let's take a few examples. So a customer is running version 10.4 Defense Pro, okay, with DNS protection on. So he's running version 10.4, okay, and he was making use of DNS protection, but he had a valid application protection subscription as well, and he was looking to upgrade to 10.5. In this case, he can go ahead with the upgrade to 10.5 because he has a application protection subscription. So DNS protection would still be active. So it works seamlessly. So this case is okay. Next situation is something like this. The customer is still running version 10.4. He still need DNS protection, but he does not have a valid application protection subscription, but he wants to upgrade it to version 10.5. In this case, if he directly upgrades from 10.4 to 10.5 and he still needs DNS protection, after the version is upgraded to version 10.5, the DNS protection will not be available because post version 10.5, we have moved the DNS protection to the application protection subscription license. So before update, make sure that you have application protection subscription purchased. Otherwise, if you directly upgrade it, post upgrade, the DNS protection will stop working. Okay. So make sure that you have the application protection subscription in place. Okay. So here again, the customer is running version 10.5 or higher with the new DNS protection on, has a valid application protection, but is about to expire. Then in that case, the customer will be notified 45 days prior to the application protection subscription expiry that kindly renew the particular subscription. So if it is about to expire on 11th June, you will start getting notifications 45 days prior to this expiry date that kindly update the application protection subscription, or otherwise the DNS protection will stop working. So do update it accordingly. So summary. So DNS protection, so it is very accurate. The time to mitigate is very low. It is faster. You can mitigate water torture kind of attacks as well very easily based on the AI engine that we have in store. It is highly accurate because it is making use of BDOS engine. You can identify real-time network flooding DNS kind of attacks, okay, and it can be mitigated very quickly. You have name server challenge as well, used to protect authoritative name servers. If there are spoofing involved, then the name server challenge will kick in. It will challenge the source. Only if the source provides us with an appropriate response, we will be opening a backend connection to the name server. Otherwise, we will be simply dropping the traffic. Okay. And again, the attack coverage mitigation is high because we are using allow list, we are using BDOS, we are using name server challenges, we are also making use of rate limit as well. So all those works in tandem and you can basically mitigate any kind of DNS kind of attacks completely. Okay, so the new DNS protection, it is accurate, it is automated using AI, it has the shortest mean time to resolve, and it is a rule-free approach. That means you do not have to do much of the configurations. Everything is primarily done automatically by the Defense Pro. So that was all about DNS flood protection. So before going ahead, let's have a 10 minutes break and then we can then we can continue with the next set of presentations. So let's resume. So welcome back everyone. So the next topic for the day is SYN flood protection. So here we'll be understanding how we protect against SYN flood attacks and how Defense Pro works in order to protect against SYN flood attacks. So the threat coverage. So SYN flood will protect you against these kind of attacks: SYN flood, empty connection flood, HTTP GET floods, reflection attack, and carpet bombing. So these are the 5 attack vectors which are protected, okay, when we use SYN protection. So let's have a look. There's a small video explaining the same. So let's have a look at it.
What is a TCP SYN flood? Hi everyone, I'm Eva and welcome to another Radware Minute. A TCP SYN flood is a type of DDoS attack that exploits the TCP connection process. Normally, to connect a server using the TCP protocol, a connection request, a SYN message, is sent to the server. The server acknowledges this request by sending back a SYN ACK message. This response is acknowledged by an ACK message and a connection is established. Now, how does a SYN flood attack work? A SYN flood occurs by sending thousands of connection requests to a target server using spoofed source IP addresses to initiate this TCP three-way handshake. The target server attempts to open all those connections by acknowledging all the requests and ends up waiting for ACK messages that never come. These requests overwhelm the target server, making it unresponsive, and in some cases can also result in the target server crashing completely. To stay fully protected from those SYN floods and other forms of DDoS attack, you should implement a DDoS protection solution that is able to handle the scale and sophistication of these attacks. Thank you for joining us on this Radware Minute, and stay safe.
So that explained what SYN flood attack looks like and how the SYN flood operates. So let's understand in depth. So the user, whenever he wants to talk with a server, he will send out SYN messages. The server will respond with a SYN ACK and the user acknowledges it by sending an ACK response. So this is a three-way handshake which is performed in order to establish the initial connection. But if it is a spoofed IP, then in that case, we never get the ACK messages in response. Okay, so we will not get the ACK messages in response, and that basically leads to the sessions being open for infinite duration. Okay, so the sessions are open. We are not utilizing the session, and the legitimate users, if they are trying to access a resource, okay, the main server will not be able to handle those requests because it is busy handling the transaction which is opened by the hacker. So this is the attack, simpler attack, and how we can tackle this is what we are gonna learn in the upcoming presentations. So simpler attack. So the attacker can take control of multiple PCs and those IP addresses can be spoofed and the attack can be launched from those IP addresses which are spoofed, basically bringing the public server down. Okay, so you can send SYN floods via multiple PCs. Okay, the server will respond with a SYN ACK, but we will not receive an ACK response back. And that's where the public server will drain all its resources. The CPU and memory consumption would be very high. Eventually, it crashes down. Okay. And legitimate users, if they're trying to access this, won't be able to establish a connection. So this we need to stop. And that's what we do when it comes to the SYN flood protection. Empty connection flood. Now, this is kind of a SYN flood attack, but here the TCP three-way handshake is completed. Okay, so it is coming from a legit source, let's suppose. So here the three-way handshake is completed, but the user is not sending any data. So it's like we have opened the session, but we are purposely not sending any data. It is as good as not connecting, right? So we have connected it, but we are not utilizing a data. Basically, we are making sure that the other legitimate clients won't be able to make use of the resources which are available at the main public server. Okay. So hackers would just open the connection. They will not be requesting anything, neither they will be sending any data. So it's just empty connection with the public server so that legit clients won't be able to access the resource. Another kind of a denial of service attack. Then we have HTTP get flood attacks. Now this is where the things get tricky. So here we are sending a lot of HTTP get messages. Okay. We have established a three-way handshake and post that we are sending the get messages, a lot of get messages, basically overwhelming the public web server. Again, we have established a connection. Post establishment of the connection, we are sending a large amount of requests, eventually bringing down the server. Next, we have carpet bombing. Carpet bombing is a type of attack where not just a single IP is targeted, multiple IP addresses in the attacked organization would be targeted. It will not be just a single IP. There might be multiple IPs within the network that would be targeted at the same time. So that is known as carpet bombing. So defense through SYN protection, how we protect and how we mitigate. So that's something we need to look into here under this set of presentations. So first of all, the sin flood protection is rate based. Okay. So we have to set a certain threshold. If that threshold is breached, then on we perform challenge response mechanism. So it consists of two parts primarily. One, that it is rate based. So first of all, we need to set a certain threshold level. Okay. And once that threshold is breached, we will challenge every client. Okay. Post that, we will challenge every client. So this is the mechanism. We first of all set a threshold level, and once the threshold is breached, we will challenge every client. Okay. So it works something like this. The user will send a SYN request. Okay. Defense Pro will send SYN-ACK, and the user will send an ACK. Now, this is a legitimate three-way handshake. If this is the case, we will establish a connection with the backend server. Okay. This is in normal scenario, right? Now, in case of an attack, we have a threshold level. Okay. The threshold is set to 2500 SYNs per second. So at max, we can have up to 2500 SYN packets per second receiving at the defense pro end. Now, if this threshold is breached, that means let's suppose we get 2510 SYN packets per second at the moment. Now, if this threshold is breached, what we do is that we start challenging the clients. Okay. We start challenging the clients which are coming after this. Okay. We'll start challenging the client. Okay. And if the response is proper, if you're getting a proper response from the client, then only we will open a backend connection with the public server. Otherwise, we will not open a connection. Let's suppose the Defense Pro challenged the client and the client was unable to provide the proper response. Then in that case, we will not establish a three-way handshake between the user and the public server. Okay, we will not establish a backend connection and we will simply be dropping the packets. Okay. So first of all, we need to set a threshold stating that how many SYN packets are we okay with. Okay. And if that threshold is breached, then we will start challenging the clients. Yusuf, the challenge is basically, I'll be explaining you, it is in the upcoming presentations, okay? So I'll explain what are the challenges that we are doing. So right now, as of now, the rate based is threshold, okay? And the challenge is being sent from the Defense Pro towards the user, and the user will send a response back. If it is proper, then they will be establishing a backend connection with the server. Now, along with, so there are two threshold levels, okay? So one is your activation threshold. One is your activation threshold, and the second one is your termination threshold. Okay. So there are two threshold levels. Activation threshold is, let's suppose, 2500. Termination is 1500, let's suppose. Now, taking this into account, let's look at the next slide. So this is your activation threshold, which is mentioned here, which is 2500. And this is the termination threshold set at 1500. Now let's see how the SYN flood protection works. So this is the threshold level that we have set. So once the number of SYN packets goes above 2500, okay, once the SYN packets goes above 2500 per second, then we will start the challenging. At this point, we will start challenging the clients, okay, and we will continue challenging the clients until it goes below the termination threshold. Okay. Until it goes below the termination threshold, we will continue the challenge. I'll explain it once again. There are two threshold levels, activation threshold and termination threshold. Activation is set at 2500, termination is set to 1500. These values are configurable. Okay. Now, if the number of SYN packets that we are receiving goes above the activation threshold, we will start challenging. So we start the challenge at this point, okay, and we will continue challenging all the clients until the number of SYN packets goes below 1500. Okay. Only if it goes below 1500, we will stop the challenge. So the challenge exists from this duration to this duration. Okay. And post termination threshold, we will stop the challenge and the clients can open a backend connection with the server. So make sure that you understand this thing. And based on that, you will be configuring the SYN flood protection. So it is rate based, right? So it is rate based. You have to set a certain threshold. There is no signature protection involved here. It is based on challenge response mechanism. There is no minimal impact because most of the times it is handled by the DME if it is a hardware based product that you have. And it is high speed and can mitigate SYN attack of up to 330 million packets per second. And it can be configured in symmetric and asymmetric ingress environments. Okay. So let's now look at the challenges mechanism. Okay. So the first challenge is the transparent proxy. Okay. So this is the first challenge which you're using, SYN flood challenge or transparent proxy. So here, what we are doing is that we're sending a SYN packet. Okay. This is after the threshold is breached. Okay. Only after the threshold is breached, that means activation threshold is breached, we will start challenging the clients. Okay. So whenever the threshold is breached and the user sends a SYN message to the defense pro, the defense pro will send out a SYNAC. Okay. It will send a SYNAC. Along with it, it will send a cookie. Along with that, it will send a cookie. Now, this is not the layer 7 cookie that we're talking about. It is a set of parameters which are present within the SYN. So what some of the parameters are present within the SYN, those parameters are taken into account, and basically it's a string of characters that we're sending back to the user. It is known as cookie. Okay. So this is sent back to the user only if the user sends the ACK response along with this cookie. Okay. If the user responds with an ACK response along with this cookie value, then we will basically authenticate that particular client. So Defense Pro, if it receives this response back, then the cookie is validated. Then the Defense Pro will allow the user to establish a backend connection with the server. Then it establishes that the client is authenticated. He or she can basically open the direct connection to the backend server. Now, this SYN cookie is not really a cookie. Okay, in TCP, there is no dedicated field for a cookie, as you know. The SYN cookie includes the initial sequence number, okay, which instead of being random as in a normal TCP packet, it is basically a hash of several parameters that are visible in the SYN packet combined with a timestamp. So SYN cookie is not your traditional layer 7 cookie, okay. It consists of an initial sequence number, okay, which is present within the initial SYN packet that is coming, and it is a hash of multiple parameters that are visible in the SYN packet, okay, and along with a timestamp. So it would be unique. So once that is received, we send that particular hashed value back to the user. The user has to respond back with a ACK response along with that hash value. If that particular response is received at the Defense Pro, then we basically establish a backend connection to the server, something like this, and they can establish a communication. If not, okay, if this response is not received, we will simply be dropping that particular request and the backend connection to the server is hampered. We do not open a backend connection unless and until we receive this cookie back in the response from the client. And transparent proxy challenge only works in symmetric setups. Okay. So it works only in symmetric setups. So we have a question from Mehmet. So if both BDOS and SYN-flood protection are enabled at the same time, which one is activated first? So good question. I'll be sharing you a document which basically explains which protection module has a higher preference. Okay. So I'll be sharing the detail with you. Okay. So ideally, both should be enabled. Both BDOS and SYN-flood protection can be enabled. Okay. So there are situations where the SYN-flood protection might be disabled, and I'll explain. There is one drawback when it comes to SYN-flood protection. I'll explain that. During that, I'll cover why both BDOS and SYN flood protection need to be enabled. Okay. Right now, that was a very good question from you. I'll basically send those documents with you, which protection modules come first and which will be enabled later. Okay. Just remind me, okay, of that particular part. So coming to the transparent proxy, now transparent proxy is only applicable for symmetric environments. It is not possible to use this for asymmetric environments because we are looking at the responses as well. So it does not work in asymmetric environment. For asymmetric environment, there is a separate challenge altogether, which is known as safe reset. Okay. So coming to this, so if it's a spoofed IP, okay, we will send a challenge back to the client. But since this is a spoofed IP, we will not get the response back. Okay, so we will not get the response back and the connection would be dropped by the defense pro because it is coming from a spoofed source side. So this is how it works. So first of all, the client is sending a SYN. Okay, whatever parameters are present within the SYN. Okay, we are taking certain parameters, we are hashing the value of this parameters and we are generating a string and we are sending that back to the client along with a SYN-ACK. If it is a legitimate client, the client would be able to send the ACK response along with this hashed content. Okay. Once this is done, okay, if we get the response, the defense pro authenticates the client. Okay. It will authenticate the client at this particular point. Okay, it authenticates the client and then the client can basically open a backend connection with the protected server. Okay. So that's one part. So let's have a look at the ACK verification flow. So the first ACK packet is stored in the request table. Okay. So at this particular point, okay, once we receive the ACK response along with the cookie, at this point, we are basically authenticating that the client is legitimate. Okay. So now this ACK packet is present in the request table. Now, once this is done, we can primarily open a connection from the client towards a protected server, okay, which is this part. But let's have a look. So now the client tries to open a backend connection with the real server or the protected server. So it sends a SYN message. Before the three-way handshake could complete, okay, before the three-way handshake could complete, the client has already sent the first data. Okay, the client has already sent the first data. Now, the first data packet replaces the ACK in the request table. Okay. If it arrives before the three-way handshake is completed with the server side. Now, before this three-way handshake is completed, the first data is already sent by the client. Now, in that case, what we do is that we replace the ACK with the first data packet. Okay. We replace the ACK with the first data packet. Okay. So SYN-ACK is sent, and instead of sending the ACK, we will be sending the first data along with the ACK. Okay. Along with the ACK, we'll also be sending the first data. Okay, because we have already stored the first data in the request table. Now, if we also send the second data, third data, those data would be dropped. Okay. Only the first data packet would be stored in the request table. The main thing here is ACK verification flow. The main idea here is that whenever, so I'll explain this once again. So we get a SYN packet at the defense pro. Okay. The defense pro will send a SYN-ACK back along with the hashed content. And if we receive the ACK response along with this hashed content back again to the defense pro, at this point in time, the client is authenticated by the defense pro as a legitimate client. Okay. From there on, we can establish a connection with the backend server. So defense pro tries to open a session with the backend server sending the SYN. Okay, but before this three-way handshake could be completed, the client already sent the first data. Okay. In that case, the defense pro will replace the ACK. It will replace the ACK with the first request, okay, or the first data. Okay. At this particular point, when the SYN-ACK is sent back, the defense pro will send out the ACK along with the first data. So three-way handshake is completed. Also, the first data communication is being done. And thereon, the client and the server can basically establish a connection and then all the data can be transmitted between the client and the protected server. Now, this is known as ACK verification flow because at this point we are authenticating the client to be legitimate. Next, we have data verification flow. Okay. Next, we have data verification flow. It is similar, like we send a SYN. Okay. The defense pro send a SYN-ACK back along with the cookie. The client sends the ACK along with the cookie. In the previous presentation, we were authenticating the client at this point, right? But at the data verification flow, what we do is that we wait until the first data packet is received. So once this is done, we wait for the first data packet to be received. So once that data arrives along with the cookie, at this particular point, we will be authenticating the client to be legitimate. Okay. So that's where that's why it is known as data verification flow. Rest everything remains the same. Okay. Rest everything remains the same. Okay, that means the first data packet is stored in the request table. Okay, ACK packet can include the first data packet. Rest everything remains the same. Only this part is different, is that we will wait for 8 seconds till the first data packet is received. Now this is done so that we can eliminate empty connection flood kind of attacks. So what was empty connection flood attack? In that the session was open, but post the session opening, the data packets were not sent from the client towards the defense pro. Okay, so that's what we are stopping with the help of data verification flow. So here, after waiting for 8 seconds, the first data, if it is received, we will authenticate the client. So this is your data verification flow. Ali, do you have a doubt?
Yeah, can we have a quick, brief looking at the previous slide?
This one?
Yeah, this one, the scene one.
Okay. What's your doubt?
I couldn't get the egg and the cookie section.
Okay, okay. I'll just repeat it. So this is your transparent proxy, okay? So transparent proxy. So this is the challenge mechanism which is done when the threshold is breached. So right now the activation threshold has been breached and now the defense pro has to challenge the incoming clients. Okay. So let's suppose activation threshold is breached at the moment and this client is trying to make a connection request to the defense pro. So the client sends a SYN message to the defense pro, right? Defense pro is basically at this point in time challenging the client. Okay, so this is the challenge. So along with the SYN-ACK which is being sent by the defense pro is also sending a challenge. Okay. At this point, the client needs to send a ACK response. Okay, along with the response, which is basically sending back what is being sent by the defense pro. Okay, so this particular cookie is not a layer 7 cookie. It is a hash of the parameters which are present within the initial SYN request. So when the client sends a SYN packet, within the SYN packet, there might be different parameters. This cookie is nothing but a hash content of all those parameters, which is sent in return as a challenge. Okay. So when the user sends this ACK response back, okay, along with the ACK response, it also needs to send the cookie value which was sent by the defense pro. And the defense pro will authenticate this client as a legitimate client only once we receive this particular cookie in return. If we do not receive this cookie, we will not be establishing a backend connection to the protected server. We will simply drop the connection. We will simply drop the connection if we do not receive this cookie back. Okay. In that case, we consider that this is a bad client, okay, or it is coming from a spoofed source, okay, because spoofed source IPs won't be able to give the response back. But in this case, since the response is coming back along with the ACK response properly, At this point, we are considering that the client is authentic and we are authenticating the client. Okay. And that's why it is known as ACK verification flow. Why? Because when we receive the ACK response along with the cookie, we are authenticating the client. That's why it is known as ACK verification flow. Okay. Next part, since the client, yes, Ali, do you have a doubt still?
Question. What if even we didn't had a hack response?
Sorry, what?
What if we couldn't even get a hack response from the
We
client?
will simply drop the packet. As simple as
Oh,
it is.
okay. Thank you.
Okay. Do you need to go further or rest is understood?
Yeah, it's clear for me. Thank you.
Okay, perfect. Perfect. So this was ACK verification flow. Next is data verification. So in the previous slide, we were authenticating at this point, but at the data verification flow, we will be authenticating the client after we receive the first data packet. Okay. After we receive the first data packet, we will be authenticating the client at this point. Okay. So that is your data verification flow. Okay. This is used to stop empty connection flood kind of attacks, because empty connection flood, you establish a connection but do not send the data. So by incorporating this functionality, what we basically do is that we wait for the data. Only if the data is received, then we open a backend connection to the server. Otherwise, we simply drop the packet. The next challenge is safe reset. So the previous challenges were based on transparent proxy mechanism. Okay. So one limitation of transparent proxy is that it can only work in symmetric environments. Okay. So it can only work in symmetric environments, but the safe reset works in both symmetric and asymmetric environments, and hence it is the default challenging mechanism on layer 3. Okay. So this is the default challenging mechanism on layer 3 for the SYN flood protection. So here, how the safe reset works. So here, the user is sending a SYN. Okay. The defense pro is replying back with a bad ACK packet. Okay. So here, the defense pro does not respond with a SYN-ACK. It will respond with a bad ACK packet along with some value. Okay. If this is the case, then the next thing that the user must do is that he should reset that particular connection, since it is a bad ACK packet that it has received, and again try to open a SYN connection. So this is what is defined in the RFC as well. Okay, that when a SYN is sent and in response we are getting a ACK packet which is bad. Okay, and in that case the client is supposed to reset that connection and try to open a new connection with the server. So this is how it should operate in normal scenario. Okay, so this is the way. And once we receive the SYN packet again after resetting of the connection, then we authenticate that particular client and we simply establish a backend connection with the server. So this is a safe reset option. And it can be used in asymmetric environments. That's why this is the preferred operation when it comes to SYN flood protection. Again, this is the exact same thing. So SYN packet is sent. Defense Pro sends a bad ACK response, okay, with an invalid sequence number. The client should reset that particular connection. Okay. At this point, the source is listed in the contender table and authentication table. Once this is done, okay, once the client has resetted the connection, the client should again retransmit the SYN packet. And once this is done, okay, once this is done, we receive the SYN packet from the same client, as the client is already part of the contender table. Once we receive the SYN packet from the same client, we authenticate that particular client. Okay, so the client is authenticated for the next 20 minutes. So the client is authenticated for the next 20 minutes and he can establish a connection with the backend server. And post that, we can also establish data communication. Now, one important thing here is that once the client is authenticated, the client is authenticated for the next 20 minutes. Okay, so the client is authenticated for the next 20 minutes. Okay, now if this client later on performs any attack, if this client later on performs some attack, those will not be considered as an attack. Okay, it will not be mitigated by the sin flood protection. It will not be mitigated by the sin flood protection because we have considered it as a legitimate client for the next 20 minutes. So that's why it's very important that if you have enabled sin flood protection, if you have enabled sin flood protection and your authenticated client is later on performing an attack, okay, then also enable BDOS kind of protection along with it. So even if the sin flood protection fails for some reason, then the BDOS protection can kick in and it can block the attacks for you. Okay. So that's why both sin flood and BDOS protection should be enabled, and BDOS protection should be enabled every time. So this is the reason. That's what was mentioned, that that could be a disadvantage when it comes to safe reset. Or it is applicable for both safe reset and transparent proxy, because in both the scenarios, the client is getting authenticated for the 20 minutes. The advantage of safe reset, it works in both symmetric and asymmetric environments. This is again the same thing which I've already covered, TCP reset. Again, we are waiting for the data packet to be received. And once the data packet is received, then we establish a backend connection to the server. This is kind of important. So if you have SYN flood protection, so it is authenticating the client on layer 3. Okay. But you can also have HTTP authentication on layer 7. You can also have HTTP authentication on layer 7 to stop HTTP flooding kind of attacks. Okay. So here you can incorporate layer 7 kind of authentication. So Yusuf has a question when to use each one. So by default, the safe reset option is being used. Okay, that's the default operation. And it is used as a default operation because it can work in both symmetric and asymmetric environments. So you do not need to change it to TCP reset. So disadvantage of TCP, say, the transparent proxy is that it works only in symmetric environments. Okay, it cannot work in asymmetric environment. So if we have an asymmetric environment, then go with safe reset, and safe reset can work with both the scenarios. So hence safe reset is the preferred one. So stick with safe reset. So that would be a better idea. Next, we have application level challenge. I was talking about the SYN flood protection. It works. So it will basically authenticate on layer 3. If you can also enable layer 7 authentication as well, which is related to HTTP. So it will help you mitigate layer 3 as well as layer 7 DDoS kind of attacks. So this is your initial layer 3 challenge. And this is your layer 7. And more on this is covered on Defense Pro level 2. Okay, wherein we basically explain you the flow and everything. So how we mitigate layer 3, how we mitigate layer 7. So this is part of HTTPS protection, but the SYN flood protection can also help mitigate HTTPS or trigger HTTPS based flooding attacks. So also on layer 7, we can authenticate it. Okay. So more on this would be covered on level 2 training. The two challenges which are present when it comes to HTTP authentication are 302 redirect and JavaScript. Okay, so there are two mechanisms. So there are two challenges, 302 redirect and JavaScript challenges. So those two are the challenging mechanism when it comes to HTTP. So what kind of attacks can be stopped using Defense Pro SYN flood protection? So these are the answers: SYN flood, empty connection flood, HTTP get flood, and carpet bombing. Okay, so these are the four kind of attacks that can be mitigated. So can I use transparent proxy in this setup? So here the inbound traffic is flowing via this direction and the outbound traffic is flowing via completely different path. Now this kind of operation is known as asymmetric environment. Okay. In asymmetric environment, you cannot use transparent proxy because transparent proxy only works in symmetric environments. So in this kind of scenarios, you will make use of safe reset option. Okay. So here you can only make use of safe reset. So how to configure these things? So first of all, you need to enable SYN flood protection. The SYN flood protection need to be enabled. Set it under block and report mode. You need to set activation and termination thresholds. So activation threshold is set to 2500, termination is set to 1500. If the number of SYN packets per second goes above 2500, then we will start challenging every client and we will continue challenging the clients until the number of SYN packets goes below 1500. And that's what we are defining here. These are the challenging mechanisms. So here, these are the network level authentication challenging mechanism, wherein we have two methods, safe reset and transparent proxy. Safe reset is the default one, okay, which can be used in both symmetric and asymmetric environments, while transparent proxy can only be worked with symmetric kind of environments. On level 7, that is on layer 7, okay, we can make use of these two challenging methods, which is 302 direct and JavaScript. More of this would be covered in level 2, okay, Defense Pro level 2 training. Here you can enable layer 7 authentication as well. So it is a multi-layer authentication scheme wherein we'll first check whether the client is authenticated at layer 3. Once that is done, we will also check whether at layer 7 the client is authenticated. Once both these authentications are met by the client, then only we allow the client to open a connection with the backend server. So that's your SYN flood protection with layer 3 and layer 7 authentication. This is carpet bombing. So basically here, instead of targeting a single IP, we are targeting multiple IP addresses within a customer organization. Okay, the customer network, we are targeting multiple IP addresses. Here, you just need to enable these settings under the tracking method. You just need to set the activation mode to continuous. That's it. So rest everything would be taken care of. Since this is a challenge response mechanism, so if it is detected by the SYN flood, it will show SYN flood attack and the traffic would be shown as challenged. Okay, instead of dropping, it would show that it is challenging. So it is challenging the clients, and if the challenge is not successful, it will simply drop those particular connections. So that's exactly what is mentioned here as well. So action type is challenge. This is the attack rate that we are getting. So this is the average SYN packets per second that we are receiving, which is 61,200, which is very high compared to what the threshold that we have set, and hence we are challenging the clients. And the TCP challenge being used is safe reset, which is the default one. So SYN protection. So SYN flood protection, we have two methods, transparent proxy, safe reset, connection flood, TCP reset, and these are for layer 7 authentication, 302 direct and JavaScript. This is related to symmetric and asymmetric environments, so which we have already covered previously. That's a safe reset will primarily use symmetric environments and asymmetric as well. Transparent proxy does work in symmetric environments. With that, we conclude this part of the presentation. We have two more presentations left, which is related to out-of-state protection and filter. So let's take it up. So the next topic is out-of-state protection. So what is TCP out-of-state packet? If the first packet that we are receiving is not a SYN packet, then we consider that packet as out-of-state. Okay. So the normal connection is the client sending a SYN, the server responding with a SYN ACK, and the client sending back an ACK response. So that is your normal three-way handshake. But if the first packet that the server is receiving is not a SYN packet, in that case, we are considering it as an out-of-state packet. Okay. If the first packet is not a SYN, it is considered as out-of-state packet. Now, in this scenario, how to protect it? So again, this is rate based. Okay. Again, we are setting a rate that we are okay with receiving this amount of out of state packets. But if the out of state packets coming in surpasses the threshold that we have set, then we will start dropping the traffic. Okay. In out of state packet, we are not using challenge mechanism. As soon as the threshold is reached, we will be simply dropping those out of state packets. Okay. So here we are setting the threshold that we are okay with receiving 10,000 out of state packets. Okay. And if the 10,000 out of state packets per second that we are receiving is breached, then we will start dropping the packets. Okay. Then we will start dropping the packets straight away. We do not challenge those packets. Again, we have activation threshold and termination threshold set. Okay. Again, we have activation threshold being set and termination threshold is set. Okay. If it goes above the activation threshold, an attack is detected and we will start dropping of the packet. We will continue dropping all the out of state packets until we go below termination threshold. Okay. If the number of out of state packets goes below 1,500, we will stop dropping of the traffic. Okay. If the activation threshold is breached, we will start dropping of the traffic. Okay. So this is related to out of state protection. So here we need to enable out of state protection, set up the activation threshold, set up the termination threshold. Okay, once that's done, you simply start blocking the traffic. We have something known as graceful period. So this is something important when it comes to out of state protection, because let's suppose we have a defense pro. Okay. Now it was working properly. Okay. Suddenly the defense pro rebooted for some reason. Let's suppose it started rebooting, and let's suppose out of state protection was turned on. Okay. So now the defense pro just rebooted. It came back again. Now the first packet that the defense pro is receiving, let's suppose it is your SYNAC package, or let's suppose it is the ACK packet that it is receiving from the client. Instead of SYN, it is receiving ACK because the defense pro just rebooted, and the clients might be sending SYN packet. Okay. But here now the first packet that we are receiving is the ACK packet. Okay. After reboot. Now this increases the number of out of state packets after the defense pro has just rebooted. And if the out of state protection is on, immediately after the defense pro has been turned on, what it does is that it starts dropping all the packets. It starts dropping all the packets, and this leads to some issues. So what we are doing is that suppose if the defense pro gets rebooted for some reason, okay, there is a grace period set. Okay, so there is a grace period set of 1,800 seconds or 30 minutes by default. Okay. So what we do is that after the reboot, we turn off the out of state protection. We turn off the out of state protection, okay, till the 30 minutes. Okay, only after 30 minutes, we will start checking whether we are receiving out of state packets. Okay, so that is the global, or the startup mode is graceful. That we wait for 30 minutes to make sure that the packets that we are receiving is learned after 30 minutes. Okay, so that is your graceful period. So this is one important feature. With the help, with this, you can reduce the false positives. So this is something related to the CLI commands, where you can basically check whether the out of state protection is enabled or whether it is in graceful action. So you can run this command, and with the help of that, you can check whether the out of state protection is enabled or not. Again, reporting part. If the attack is detected by out of state, it will show under attack, but the event name would show as TCP handshake violation. Okay, it will not show out of state. It will show TCP handshake violation, first packet not sent. So if you see something like this, you can simply understand it is out of state packet. Okay, and it would be under category of anomalies. And the attack type would be drop, and the source port is this. So all these things. So out of state protection, it is just rate based. If that rate is breached, then we will simply be dropping the packet. This is again not a challenge response. Here we'll be simply dropping the packet. So with that, we conclude this presentation as well. So we have one presentation left, but I'll be taking it tomorrow, okay, because we have very limited presentations for tomorrow. So it would be better if we take the presentations later, Okay, the traffic filter I will take tomorrow. You can continue with the labs. Okay. Because yesterday few participants were unable to do the labs because they were not able to onboard the Defense Pro as well. Okay, so it would give them time as well to practice once the labs are fixed. So I'll take the traffic filters tomorrow, and that's it. So I have completed with my part, which is the presentations. Rest we can continue tomorrow related, and you can continue with the labs as of now. Yes, Yusuf, I'll be sharing the table of IDs and password. Sure.